Hello, everyone. I'm Pam Turner, Marketing Director at Eccentric. I want to thank everyone for joining us today for the webinar, The Rapid Prototyping Process. Our featured speaker today is Craig Johnson. Craig is an account executive with Eccentric and has a mechanical engineering degree from Northeastern University. He has extensive experience in manufacturing design and validation, working for many years helping customers through the rapid prototyping portion of both development and manufacturing. Also joining us today is John Sidorowitz. John is Vice President of Inside Sales and Customer Service at Eccentric. He is a technically minded sales leader and problem solver in all things manufacturing. John has a degree in management and a diverse background and understanding of the entire manufacturing process from design through final product. Now I will turn it over to you, Craig.
Thank you so much, Pam. Thank you, everybody, for attending as well. Look forward to chatting with you all about this topic. It's something that I'm pretty passionate about. I've been working around for quite a while now, and I feel like engineers really should be kind of utilizing the rapid prototyping process just to help cut down some costs while speeding up turnaround times. So for today, I plan on going through an overview of that rapid prototyping process that I was talking about earlier, the time and financial impact of skipping the prototyping process, using that process to prioritize and minimize risks, identify the potential impact of not following that rapid prototyping process and how it could affect a various given project, and then where Eccentric fits and how we might be able to help with that rapid prototyping process and going through that design. So to start, I'm going to kind of address the elephant in the room, like why do engineers kind of skip prototyping in general, or designers skip prototyping? And it tends to be, at least from my experience, that product designers as well as engineers tend to skip prototyping because it's kind of the easy place to just look at it kind of a line item and be like, oh, we can just cut this out and it will quickly reduce costs, or basically just skip a section that might not necessarily be there. We can trust our engineers and just skip it and go with based on what they did on CAD and just kind of trust it. When in reality, making that assumption early in the process can really cause expensive, unforeseen delays later on, because the earlier you're able to recognize these issues, the better it's going to result, because making things later on in the process is going to be a much more significant impact, which I'll go into later. So some of the common misconceptions that we hear is going to be, why do, basically it is going to increase time to market by skipping this step, or well, doing the step rather, increase time to market. And the answer to that is really no. Prototyping is considered a bottleneck by a lot of people, but that's a misconception. That isn't always the place where you're going to run into issues. And people think that they can kind of go through it by just doing makeshift proof of concept models that are quick and dirty, and they can use kind of a quick and dirty prototype to just get through it and kind of rush through that step to get to market faster, because they feel like if you do an early step quicker, it's going to get you to the end goal faster. When in reality, skipping early steps in that prototyping cycle might cause you to actually miss very important factors in terms of the kind of issues that you'd run into later on in manufacturing, and things that would quickly snowball and cause heavier issues moving forward, which I believe we do have a polling question around this as well. If Pam, would you mind putting that polling question up just in order to kind of see where some of the people in attendance might kind of use models and prototypes? Oh, I didn't just stop presenting 1 second. Okay, perfect. So the poll came in. So it does look like a lot of people do some prototyping in-house using one of their own machines, but also some people outsource. But luckily, it seems like most people here do use some sort of physical prototype to some extent, which is great to see. Another misconception we see is that by skipping the prototyping process, that you're going to actually be able to create products for less costs, because you are skipping steps that do have costs associated with them. So they'll run something in-house that the misconception is that running something in-house is going to be very expensive. Maybe investing in a 3D printer or investing in a injection molding machine or something along those lines, or a CNC, is going to be a very large upfront investment. So why not just skip this step altogether? It's going to either save investment in money in investing in machinery or investing in a service, and that we can always just figure this out once we get to production, make the changes then. It's probably going to be a very small cost, don't have to worry about it. When in reality, prototyping and production tooling are not the same at all. It might seem like a logical way to save money by making changes at the production stage and kind of just rushing to get the product out as quickly as possible. But in reality, taking the extra time, going that extra step early on and running that extra model, maybe doing that extra validation, that extra meeting with a physical present model in hand to do a fit check, do some validation, is just going to make it so once you get to that production tooling, you're already going to have worked through all of those issues that might come up. Because once you get to production tooling, as you'll see later on, those changes are extremely expensive compared to, say, finding something during the 3D printing stage or the very first run that wouldn't be as costly, which I do believe there is another polling question after this as well. So have you ever needed a production have you ever had a production tool produce a part that needed engineering changes after the first shot? Give you just a couple seconds to answer that one. All right, so as I kind of made some assumptions in the previous slide, it does look like people have ran into scenarios where they have gone to a production tool, ran a first shot, and have noticed that production or engineering changes were needed. And I'm sure, as shown in this poll, quickly can put you over budget when you run into an issue in that step. That said, when you're able to uncover those things earlier on in the design process, I mean, it's going to be factors of 10x plus in terms of the cost and time savings, which I'll go into a little bit further in a second. So what is the rapid prototyping process and why really does it matter? So another term I've used or heard frequently used kind of in conjunction with rapid prototyping is agile manufacturing, kind of just a way of doing things piecewise and just doing things very thoroughly in an iterative process in order to make sure that you really thoroughly design something properly. So what is it? It's a safe, fast, and time-effective process to enable you to get your concepts or your ideas from either your brain, brainstorming, whiteboard, or CAD, and advance them through the prototyping process and physical builds to validate it and then bring it to production. In the middle of that prototyping stage, you get a feedback loop that allows you to really quickly and effectively go through iterations and do real world testing with either very wide range of 3D printing options there with materials to really get some material testing, or same goes for prototyping tooling as well as CNC to really work through a lot of that real world testing and bring a physical model to work through advanced engineering problems. Also allows you to move very quickly and accurately because in general, CAD data is great, but it's always hard to get a perfect scale or representation of what you see on a computer screen in your head versus saying something that's physically in front of you that you can reach out, touch, feel, and use that to keep iterating, keep reviewing, keep rebuilding, and keep just improving. And yeah, it sounds like you'll be making a decent amount of parts, but you're also making small improvements each way that save you cost down the line. So basically what you're doing is going through that prototyping process to produce very specific parts to make it so, yeah, you're spending money up front in order to minimize that cost later on and have as few unforeseen issues come up as possible. One thing I'm just going to emphasize throughout kind of the whole thing is that every step in this process is important, and really skipping one step in the engineering process as a whole could really lead to so many unforeseen issues. And what if I could tell you that I could get you 5 physical designs in front of your customer and promise 25 samples and production within 3 weeks? How do you think that that would change the conversation that you're having with your customers? If you could say, hey, here's 5 different versions of your design, which of these 5 do you want to go with and what seems the best to you? And by the way, I can also get this into production in 3 weeks. Like, how do you think that that would change the table conversation that you're having with your customer, and how do you think that they would be receptive to that? So basically, Rapid Prototype provides a low-risk, fast turnaround opportunity to explore concepts. So you'll have a physical design that you can talk through, go through the brainstorming process in a much more in-depth way, and maybe explore various features or various options that otherwise you'd kind of just be working from paper or from a CAD screen, which it just doesn't provide scale or accuracy in the same light. Also, just allows you to design further. So you can go into just more depth. Anytime you can engineer one step further and go that extra question and that extra design problem and work through it, you're just going to create a better and lower risk design for later on when you get to manufacturing. Allows you to make better comparisons. So you can do two physical representations next to each other. I've worked at a lot of companies where, hey, they might just do one physical model and they'll use that physical model to compare against their CAD. You still run into the same issues. You're still comparing something against CAD, which maybe you're better at it than me, but trying to get scale off of a CAD file, even when you see the use the measuring tool and see like 2 inches, like in reality, 2 inches on a screen, when you zoom in, might mess with your brain a little bit and not actually seem like 2 inches. So you're not making a perfect comparison versus, say, if I physically print it out, put them next to each other and just actually see what that 2 inches looks like in real life versus zooming in and out on a computer screen. Also allows you to test more thoroughly to prevent those costly changes later on. So everybody knows that going through testing, especially for a part that is going to require a lot of functionality involved with it, is an extremely important step. You don't want to produce a part that just doesn't work. So everybody needs to test something, especially when there's a lot of functionality going on. Rapid prototyping allows you to go through all of that testing and through all of those various the variables that would factor into something not going right. So you can really scale down and localize the things that you're trying to test and the things that might be at risk, and work through the very, very specific materials, through the specific designs, and just get that peace of mind that you're looking for, that it's just going to work the first time. Also, by working through prototyping, you're going to figure out where the actual bottlenecks will be. So earlier I said that a lot of people think of prototyping as the bottleneck, when in reality, the only reason people think of prototyping as the bottleneck is because they're finding bottlenecks that would be uncovered later on. So prototyping is almost like shooting the messenger. They're the ones that provide you the data with what you need to make a more informed decision. And because they're the ones always providing you with that data, it might come across as being a bottleneck, when in reality, you're figuring out where those future bottlenecks are, addressing them as early on in the process as possible, and figuring out how to redesign things to make it so that bottleneck that you uncover actually isn't a bottleneck later on. Also allows you to just implement changes faster and get things done quicker. Anytime you can, say, go from CAD to a physical model, get a in-depth conversation going and explore a concept further, and then just get another physical model a week later or a few days later, something along those lines. It's just going to allow you to just go through more changes, implement changes faster, and just get a higher quality product made. I believe we also have another poll question, Pam. Could you put that up in a second? All right, perfect. So, wow, everybody seems to be in agreement. So it looks like, as you all agree, prototypes are used frequently to make changes. And anytime you can get a more accurate prototype, and anytime you can produce that design and really nail it down, you're just going to get that peace of mind you need. So glad to see that everybody's already following a really, really good process, and glad to see you guys see the value in that physical prototyping aspect. And just going to go through this slide quickly, just because I do believe we've gone through this a little bit, but basically the prototyping and development process, it's a very defined process at this point. It's something that engineers for a very long time have been using, and it's a very validated process, and each phase is there to iterate upon, generate more information, and use that information to continue to advance your product to production, work through and address all of the problems that might come up, and kind of work through the aspects of that to get your product developed and produced. And in general, I'm a very firm believer that whenever you're working through something that has a lot of, I would say, phases or a lot of different moving pieces going involved, I'm a firm believer that you should let the experts do what the experts do. There's no, I guess I won't say no, but it's very rare for you to find an engineer that's a true jack of all trades. They know the ins and outs of 3D printing, CNC, machining, injection molding, you name it, like the financial aspect of it as well, design for manufacturing. Like, it's very rare to find somebody that can do absolutely everything perfectly. And even you can say that across most companies as well. Usually companies tend to have a very specific focus and do what they do best, and then they tend to either maybe fake it till they make it, or try to figure out where to fill in the gaps, or they'll reach out to a service that is special specialized in a specific thing that maybe they're lacking. And that tends to be where we fit in. But basically, in general, what I'm getting at is working with the best tool or resource you can for each specific step, and working with resources that might be able to shed more light, especially early on in the process, will just improve this workflow, make going from step to step more efficient, more effective, and just make it so you don't run into unforeseen issues down the line. So it's basically a very defined process, and it's really worth following just because it's tried, true, and proven out. Also, as I've been saying, like investing earlier in the prototyping process will just make it so everything is handled as efficiently as possible. The earlier you get involved with your customers in terms of these types of engagements around critical issues that might be coming up, design for manufacturing, what actual timelines look like, what's the exact need a part needs to be in somebody's hands, when maybe the conversation's happening with investors, where you need to really bring what the best thing you can to the table is, basically figuring out what all of those need buy dates and qualifications and necessities are earlier in the engagement makes it so every person you work with, every tool you maybe need to schedule time on, things of that nature is handled as efficiently as possible. And you're not having to spend extra money dealing with fires, putting out fires and dealing with emergencies, because whenever you shorten a timeline, whenever you add a factor that causes it to be more of an emergency and a make or break type of scenario, that's just going to quickly ramp up the pricing. So the earlier you can get on top of that and make sure you address them, makes it so when things truly become critical and things can't go wrong, you don't have to worry about it. You have the peace of mind that it won't go wrong because you already worked through those issues. And as I was saying before, really the pricing ramps up heavily as you get longer into the process. So and it's pretty much a factor of 10 from step to step. And so whether you go from basically just the whiteboards, the idea phase, that's going to be obviously the most cheap because it has the least investment. Then design phase, you're going to have people doing things on CAD, takes more engineering time, more time involved. Then you get to rapid prototyping. That's going to be involving either aluminum tooling, 3D printers, maybe 3-axis, 5-axis CNCs, things of that nature. So it's going to be more engineering time, more machinery time, things of that nature, as well as more validation. Then it's going to go to prototyping tooling. I'd say that's where we tend to fit in best. Still going to be a bit more expensive than some of the other rapid prototyping aspects, but in this phase, you're able to really do a lot of your design and DFM work and get that validated down, work through a lot of those changes that maybe were missed in the rapid prototyping stage just because 3D printing doesn't necessarily find everything, and then work through those before getting to production tooling, because for every small thing that you need to do once it gets to production, it's a 10x price versus if you were to find it earlier, maybe even 100x price. So it's extremely important to get through all of these, make the changes and corrections as early in the process as possible, because once you get to a production tool where you're expecting to hit millions of quantities, things are going to be extremely expensive at that point. Okay. So as we've noticed that there has been, especially lately, a trend that US-based parts and conversations is important, and seeing that is kind of a theme seen by the attendees as well. Great to see. I'll go into this a little bit more later. We are US-based, and I'll explain that more. So as I was saying in the last slide, really getting things figured out as early as possible is going to be important. But I'd say that's even amplified more when dealing overseas, because you're also adding more factors into the equation in terms of making engineering changes, or maybe if things aren't perfect, you're dealing with a significant time difference, maybe some language barriers, maybe significantly extra timing for shipments, things of that nature. That's just going to add significantly more time to it. So if you make these changes like after production when the steel tool is cut, it's going to be just extremely expensive, time consuming, and more likely than not frustrating trying to make sure you get the changes done correctly and have that peace of mind that even the design change was done right. And not only that, you're adding a lot of time to it. Well, if you follow more of the prototype mold stage and get this done early on, you'll be able to work through it extremely quickly. get through it, have those conversations extremely quickly, get the engineering changes implemented in a fast manner and an efficient manner, and then just get going and get to that next phase of production quick without that very long delay of having a steel tool cut and then moving that route. Also, doing more work like CNC benching, texturing on a steel tool is also just going to add more time to it as well, just because working and modifying steel is going to be a lot more difficult and time consuming, and you're going to lose a lot of that flexibility around setup and trial going that route versus working with more pre-validation and prototyping tooling. So what sort of issues can be uncovered by working with prototyping tooling, since they aren't necessarily created equally? And it's going to be the ability to get feedback on dimensional issues. So getting those, for example, in our process, getting 25 free samples, checking them out, getting the validation on those dimensional issues, seeing if any changes need to be done, and working through that as quickly as possible. Also, you're going to see how the material behaves differently in an injection molding process versus, say, maybe a 3D printing process or a machined plastic process or something like that. There's a lot of factors that go into plastics that might not get uncovered until you actually melt that plastic down and inject it. Things like shrinkage, warp, sink, splay, aesthetics might get affected, and this is the type of thing that you would never see until you run that first shot. So running it in a lower risk atmosphere is just going to give you the ability to work through those design changes in a much more efficient manner. So pretty much a lot of this can get summed down in risk severity through design interactions. So what I mean by that is the rapid prototyping process kind of is very defined in a risk severity kind of way. And I think that's what I've been getting at. And I mean risk from a both time and money perspective. So working through CAD is always going to be how people start. So I guess whiteboard and then CAD, and working through those engineering problems from a high level is always going to be how people start, and that's very low risk. And then people will start building on that to produce physical prototypes using 3D printing in order to work through some of the form, fit, and prototyping. And this is very low risk because in general, 3D printing is going to be the lowest cost form of doing a quick and dirty mock-up of something. I like to think of this as like a simulation that you might run on a software, but it's just a physical simulation instead of just using a software, because software can't do everything that a physical prototype can do. So you kind of simulate what that part looks like in a very low risk kind of way using 3D printing. Use that to work through some of the, let's say, high level problems and more coarse issues. And then once you get those types of problems worked through, you can start bridging injection molding, or bridging to injection molding either through CNC or starting working through more advanced type of problems like the actual material characteristics or actual surface finishes that you'd be dealing with injection molding, shrinkage, things of that nature. So basically you use the low risk stuff to work through the higher level problems, and then start working through to get a little bit more granular and working through more of the DFM type of problems as you progress through that rapid prototyping process. So as I was saying before, so typically 3D printing is going to be the cheap and quick option, but it has the issues of being a little bit less functional, harder to do in-house depending on the size of the project you have, and it's really only good for low volumes because it's going to be a heavy time bottleneck, but also at higher volumes, 3D printing will not be the best from a cost perspective. So it's great for concept models, functional models, and pre-production. CNC, I'd say, is going to be in a similar route, and it's going to be very let's say project dependent and what sort of functionality you need to validate. So CNC will be, I'd say, more functional than 3D printing, and is going to be used for validating and proving out things that need more functionality than, say, a 3D printer is able to produce, or even very, very low batch production can also be a really good option for CNC. So it's great for concept models, functional models, pre-production models, and manufacturing to some extent, depending on the project. Then we have injection mold tooling, and I'm going to break this down into prototyping tooling and then production tooling, because as I've been saying, they are not created equally. So the big pro with prototype tooling is that it's going to be very functional, and you'll be able to work through all of really the more granular problems that you would need in order to get the peace of mind you need for production. Yes, tooling in general is going to have a higher upfront cost than, say, CNC or 3D printing would, but you're going to get a much lower per piece cost, and prototype tooling is still going to be a significantly less costly investment than production tooling. So again, it's going to be a good bridge between, say, the more coarse high-level problems, then getting through DFM to that production tooling. And in terms of our offerings, which I'll go over a little bit later, we do have a really good offering in order to scale from low, like very low quantity, say 25 units, upwards of, so let's say 100,000 or so. So it's even a really good bridge for both pre-production as well as manufacturing. Obviously, though, depending on the project and what the actual needs are of a given part. So what's the potential impact of skipping any part of the process? So I think the easiest one to understand and the easiest one that I've seen significant or happen time and again, especially prior, is working with stakeholders and either investors in terms of the concept that you're designing and the part that you're looking to produce. It's going to be a much different conversation going to an investor with, say, 2 or 3 models of a given design, being like, hey, here are the 3 parts we thought that you'd like. Which of these parts is the one that you like the most? Do you have any feedback for us? Here, let me hand this to you. You can go through the entire thing, see everything that you would want to go through. Let's talk about it in depth right now, and let's figure out if this is something that you want to go through. So basically, it allows you to test more designs and dial in the best thing for marketing / what you want to present to an investor in order to get as much of an investment and as many sales as possible. Basically, what I'm getting at is don't settle for using a 2D print or 2D like mock-up when trying to get somebody to invest in your model. It's going to be a significantly stronger conversation if you go to them with a physical prototype and say, hey, here's what we're looking to produce. Do you have feedback for us? Also, costly modifications. So if you skip things, especially functional prototypes, you're going to run into those costly engineering changes and modifications that I was talking about earlier. So you really want to work through testing fit, testing function of materials, making sure it's designed properly for manufacturability, so things are equivalent thicknesses throughout and various things are worked through. Basically, my biggest emphasis is test, test, test. Always keep testing, always keep iterating, get through that physical prototyping process and that iterative process as early as possible to make it so you're not making emergency rash decisions later on that are going to put you over your budget. And then lastly, delays and added costs, both in pre-production as well as manufacturing. As we were saying earlier, a lot of people skip this thinking that it will speed things up, when in reality, not going through all of those testings, not going through those physical samples, and not really getting that peace of mind before making a significant investment is going to be where the actual bottleneck is, where the delays come and where the costs come. You need to get that peace of mind as early as possible before you put a hefty investment into something that you're not 100% sure with. I trust engineers. I went to schooling for engineering. I've worked in design. I've worked in manufacturing. I trust my ability. I do not trust my ability to get something done right the very first time without ever seeing a physical prototype and measuring things out. So I trust engineers, but I don't trust engineers enough to know that they didn't accidentally hit the wrong button on their keyboard when they were designing things. And going through this process, make sure that that didn't happen and that you're able to catch those critical issues in small batches and custom one-offs to reduce those costs that would come down later on. So who is Eccentric? So Eccentric has been around for 23 years now. We are US based, like I asked that question earlier. We have 2 facilities out in Michigan where we do all of the cutting of our tools as well as the shooting. And you can work with one supplier, so Eccentric, through this entire process that I've laid out before. We do 3D printing, CNC, as well as injection molding, which I'll go over in a second, and we can really help you through every aspect of the rapid prototyping process. And we have very significant and experienced resources to really work through a lot of the engineering problems that I've been kind of mentioning thus far. Basically, what I'm getting at is let the experts do what experts do. Also, all of our molds are built and run on site. We've produced over 100,000 molds at this point. We can work with thousands of different engineering materials, and we do have ISO as well as ITAR and UL certifications. All right, so it does look like most people start thinking about DFM very early in the CAD development. That's awesome. That was what I was hoping to see. Does look like some people are doing it more in the production tool discussion. Hopefully, some of what I've talked about now will help see why there are more cost-effective ways to address that now. But do love to see that a lot of the people in attendance are thinking about that kind of stuff early, because I'd say, from my experience specifically, that tends to be the thing that nips people in the bud late the most is not really thinking about DFM until it gets to production, and then they're like, oh wow, we could have done this a lot better, and things just don't go perfectly. So glad to see a lot of people are thinking about that early on, and hopefully we'll be able to help out more people as well. So what are our services? Kind of summed up, they're fast and flexible. So whether it comes to geometry or materials, we want to basically produce your design. We don't want to make you take your design and fit it into our box. We want to work with basically the full gambit of design. So we want to help you through all of those complex problems. We want to get the design the way you need it made, having to make any necessarily massive design sacrifices, things of that nature. We also have the ability to do overmolding as well as two-shot molding, insert molding, many different surface finish requirements as well as custom ones, and we can do texturing as well as etching. And in terms of materials, we have 50 different resins that can be basically same-day production and have an extremely fast turnaround, as well as another 100 that will also have a very quick turnaround. In general, we're able to offer about 15 business days in terms of our production of tools and then getting parts out to you, with very frequently being able to push that up even further. And in general, we can work with just about any material you need as well. So if you do have a material that is very specifically needed for a given project or a given functionality, we usually have the ability to source and work with it. I'd say we have a very experienced team that's able to work with a wide variety of custom blended colors, custom types of materials, and various maybe more difficult materials that may have more engineering problems or constraints associated with them that we'd be happy to work with you through. And then, like I was saying before, we do injection molding, CNC, as well as additive manufacturing, also known as 3D printing. And I'd say that that's the order in which we tend to specialize in things as well. So injection molding really is our bread and butter, doing prototype injection molding to low to mid volume, and helping through those complex design problems and making it so we get the mold to produce the parts that you need for your project. That said, we also do very significant work in terms of CNC, both 3, 4, and 5-axis machines to get extremely precise parts to do either smaller runs as well as larger runs, depending on what sort of project it is and what sort of needs that you guys are looking for. And then we also have 3D printers, which I'd say I've worked in 3D printing for quite a long time, and we have just about everything you'd need there in terms of capabilities and what you'd be looking for, and help you test out those geometries, various, let's say, high-level material properties, as well as prove out those concepts. So key takeaways from this, I'd say the biggest thing is going to be that eliminating prototyping in general will increase production costs and will result in launch delays. As easy as it is to kind of brush prototyping under the rug, it's extremely risky to do so. And there's a reason why it's a very defined defined process, and why following that defined process has significant benefits associated with it. So that the process saves you time, it's very cost effective, and allows you to create realistic proof of concept models to advance them to production. All of the steps are important in their own way and build upon each other in order to bring high quality products to market on time and on budget. Production and prototyping tooling are not created equally. You want to work through as many prototypes and as many issues before getting to production as physically possible in order to prevent difficult, expensive, and time-consuming problems from occurring once that production tooling is created. Injection molding, CNC, and 3D printing each bring unique values to the stage, and each have different risks, pros, and cons associated with them. Choosing not to follow the rapid prototyping process can, and more likely than not, will result in excessive costs and expensive delays, and that it's never too early to get manufacturing partners involved in the product development process. Honestly, from my perspective, I want to help you guys out as early as physically possible. I mean, if you're still don't even necessarily have your CAD finalized, I'm still happy to get on a phone with you, talk through your project, kind of learn a little bit about what you're trying to do, and maybe help you through some of those early on engineering problems, and really start that DFM and that prototyping process as early as possible. I have no problem helping you guys out through that, and kind of sharing my expertise as well as my colleagues' engineering abilities to kind of work through those problems as early as possible, and just make sure that you have an expert with you every step of the way to just make sure it goes right. So I guess I'm going to open up the floor now to some questions.
Thank you so much, Craig, and thank you everybody for participating in our polling questions during the webinar. We do have some questions that came in, so let's start with, what is the best process for a small volume of parts?
Yeah, so I'd say it's going to really depend on what you define as small volume. So it's a hard for me to give an exact answer to that, because small volume can mean something completely different to every single customer I talk to. So I'd say in general, I like to work in the under 100,000 frame, and in that frame there is I'd say a couple different levels. If you're in the, say, 1 or 2 off, I'd say 3D printing and CNC would probably be the best option to kind of work through a very specific one-off type problem. But if it's, say, 25 parts upwards of 100,000, if that's considered small volume for you, I think working through both combination of maybe 3D printing and CNC with that prototyping tooling would be best, because you can quickly work through those early run samples, get those kind of, I'd say, I wouldn't necessarily say quick and dirty at the point of prototyping tooling, but let's say pre-production parts. Basically get the peace of mind, validate on the smaller batch, and then kind of scale up through that. So I guess maybe my question back would be given the project, is it, say, under 100 parts or over 100 parts, and then kind of have a conversation around that on what the long-term scope of the project is, what will, once things are validated, what will the project look like, and then see if maybe it makes sense to work through a couple more problems on the 3D printing and CNC side before going to prototype tooling. Or maybe the project is already kind of at that point, let's go to prototype tooling, let's get 25 samples out to you, work through that, and then figure out what the next steps are from there.
Okay, thank you. Next question is, what should I do if I am unsure of how the market will respond to my design?
Yep. So I think that's a really good scenario where our prototyping tooling can come into play. So as I said before, our prototyping tooling does come with 25 free samples. So if you have a design that's mostly ready for production, but you do want to kind of get, let's say, a temperature check of what how the market's going to respond, say maybe it's a Kickstarter for just a good example, you can get that tooling made through us. So then you have tooling ready for if, say, you have an extremely successful Kickstarter and all of a sudden need to ramp up production quickly, you'd have that tool already made where you made those 25, got those 25 free samples off of us. You can work off the lifetime guarantee on our aluminum tooling and then kind of scale up based on how those initial 25 samples go. Or if it's a scenario earlier, like I said, where you're working more with, say, investors and trying to get investor buy-in, maybe that's a scenario where you come to the table with a couple 3D prints or CNC and go that route. So I'd say it could be either work with 3D printing and CNC to maybe work with investors, or if it's more actual customers that you're working with, go the prototyping tool route, get some samples out, get some feedback, see how the reception is from there, and then either scale up with our aluminum tooling if that seems to be the volumes that you saw and the functionality that you were looking for, and kind of go from there.
Okay, great. Thank you so much. Okay, I have another one. If I have a 3D printer at home, shouldn't I be able to work through most of this?
So a 3D printer can do quite a lot, and I'd say it's going to slightly depend on which 3D printer you have, but I'd say that the big thing that I'd flag there is you have it at home. I have two 3D printers myself right next to me right now, and I'd say they're pretty higher end 3D printers for home use, and I still wouldn't feel comfortable getting peace of mind using just those 3D prints. I think it's really going to depend on the scope of the project and how functional the parts need to be. But when I hear at home 3D printer, I'm guessing it's most likely an inexpensive FDM or SLA 3D printer. And honestly, you're only going to be able to work through very high and coarse either dimensional fits, or surface finish won't be necessarily the best, or the material itself just might not have the functionality you're looking for. So yes, can 3D printers at home be used for some things? Yes, I'd say the really coarse, quick and dirty early models. But when it comes to actually validating DFM and working through more, say, material characteristics or more specific functionalities, nothing is going to really be possible, or very, very few 3D printers would be able to handle that kind of stuff, and they're going to be extremely expensive compared to, say, working with a service company such as Eccentric.
Okay, great, thank you. And when is the best time to bring a company like Eccentric into the prototyping and design process?
Yeah, so I think I think I got to this at the very end there, and I'd say as early as possible. I'd say maybe not necessarily like the whiteboard brainstorming phase, but once you guys have a design or functionality or need kind of nailed down to some extent, and you're starting those kind of mock-ups of CAD, we'd be happy to get involved at that point and kind of provide our 2 cents, at least in terms of like helping. Like we won't necessarily help you with designing for the functionality of your project, but we will help that functionality make sure it gets produced via manufacturing, if that makes sense. So we're not necessarily going to work through like the functional engineering, like this is how you need to design your part kind of way, but we will work with you through the functional, this is how you need to design your part for manufacturing portion. So as early as you can get that conversation started, the better.
Okay, thank you so much, Craig. That was our final question. To thank everybody for joining us today for the webinar. And please follow us on LinkedIn and reach out to Craig and John if you have any questions, or if there's ever anything that Eccentric can do to help with your project or provide any kind of advice or design consultation. And just thank you so much, and hope you have a wonderful day.